Students, balancing chemical equation is one of the important topic to be studied in chemistry. You might be struggled in balancing chemical equations, but there is one technique which is easier to understand and to apply the skills to balance a chemical equation, that is the ABCD method. In another way, it is one of the simple mathematical application which is applied to balance a chemical reaction. And there are several steps to be considered and to be applied to balance a chemical reaction. So let us know what are the steps or the points need to be considered to balance a chemical equation by following ABCD method. First, we need to use the coefficients ABCD for the elements present in a equation. And the next is to write the equation for the coefficient. By applying the coefficient, we need to write a reaction. What is the next? The next step is to find out the element which has the maximum number of coefficient. And we need to consider that as the 1. We need to consider that as equivalent to 1. Next, we need to solve the coefficients, and here one of the last step need to be considered is to remove the fractions from the balanced chemical equations. In chemistry, the fractionized equations are not to be considered or not to be valued. Since we need to remove the fractions from the balanced chemical equation. Now let us go with the example. Here is the working example. That is the reaction of ammonia with oxygen, which is resulting by the formation of nitric oxide and water. Here ammonia is undergoing oxidation reaction to form nitric oxide to form a water. What is the first step need to be considered, the point need to be considered? We need to use the coefficient ABCD in a equation, in a given equation. Now let us go with it. This is our reaction. What we need to do, for each of the reactants present on the left hand side as well as on the products present on the right hand side, we need to write the ABCD as coefficient. Let us go with it. Here A, B, C and D. This is the apply of coefficients for the reaction. Next step. What is next? For each element that occurs, we need to write the equation for coefficient. Coefficient equation we need to write. We have this equation where we applied the coefficients. Next, we need to write the elements of each one. How many nitrogens are there, how many oxygens are there, and how many hydrogen elements are in it. It is according to the coefficients present. Whereas here, nitrogen, if you are looking towards the nitrogen, the coefficient is A on the reactant side, as well as on the product side. What is the coefficient for nitrogen? That is C. Write it. At the same time, for the hydrogen, what is the coefficient? That is A. How many hydrogens are there? 3. That is 3A. On the product side, for the hydrogen, that is D. Coefficient is D. How many hydrogens are there? There are 2 hydrogens are there. Then it is 2D. At the same time, for the oxygen, that is oxygen coefficient is B. How many oxygens are there? 2. That is 2B. That is equivalent to oxygen on the product side is C plus D. Cross the AE on the right hand side, left hand side is equivalent to the number of C of nitrogen atoms present on the reactants product side, as well as for the hydrogen, that is 3A, and on the product side, that is 2D. As well as for oxygen, it is 2B, and C, it is equivalent to C plus D. So now let us move to know about the next step. The next is to know the coefficient that occurs for each element and how many times it occurs. Let us know, and we need to find out here which one has the maximum number, means which one is repeated for more times, that we need to find out to go further. The next point is to find the maximum number of coefficients present for each element. Okay, among the elements, which one has maximum number we need to find out. Now let us go with the nitrogen, that is coefficient is A. How many times it is repeated? Let us find out how many times the A is repeated. That is 1 and 2. So the coefficient of A is 2. And for the B, that is the oxygen, for the, not only for that oxygen or the any other element it has been related, just we need to find out how many times it has been repeated. B, how many times it is repeated? It is repeated for, it is for only one time. Then for the C, that is C for how many times? 1, 2, that is 2 times. Then for the D, that is 1 and 2, so it is repeated for 2 times. So here the to find out the coefficient which is being repeated for more than 1 times, or which has the maximum one, in that case we can say that A, B, C, D is repeated for at 2 times. So we can consider that let A as the maximum. So the coefficient which has occurred for maximum number of time is A, that is going to be equivalent to 1. The coefficient which is occurred for maximum time, that is equivalent to be 1. If it is been 3 times or 4 times, whatever it could be, but it is equivalent to 1. We need to consider that it is equivalent to 1. And the next step here, we need to solve the coefficient, since we have already identified the coefficient which has occurred for maximum time, and we need to solve the coefficient. So the maximum times which is occurred is A is equal to 2, B is equal to 1, C is equal to 2, and D is equal to 2. Since C, D and A is repeated for equal time, we are considered A is equivalent to 1. It has been assumed as A equivalent to 1. When A is assumed as 1, the equivalent is C is going to be 1. Now let us go further and solve the other coefficients, that is 3A. Next is 3A is equal to 2D. Now let us go with it. What is the value of A here? Here it is A is equivalent to 1, 3 cross 1, then 2D. Then simplify it. 3 is equivalent to 2D. Okay. Then we need to find out the value of D. That is the value of D is the 3 by 2. That is in the fraction. At the same time, we can go and solve this one. That is 2B is equal to 3 plus C plus D. 2B is equal to C plus D. Here we need to find out the value of B. We know the value of C here, that is 1, and the D we have recently come across. So let us find out the value of B. That is 2B is equal to C is 1 plus D is equivalent to 3 by 2. That is 3 by 2. Now we need to solve this one. We need to simplify this one. So if you are simplifying this, that is 2B is equal to 2 plus 3 by 2. Then B is equal to 5 by 4. So now we come across all the coefficient values. That is A is equal to 1 and C is also equal to 1. As at the same time, D is equal to 3 by 2 and B is equal to 5 by 4. Now let us put these values in a equation and balance the chemical equation by removing the fractions. So the next is to remove the fractions from the balanced equations. Since we come across the values of A, B, C, D, we have placed here A is equal to 1 as well as C is equal to 1, B is equal to 5 by 4 and D is equal to 3 by 2. That we come across it. Now let us remove the fractions by finding the LCM of the denominators present in the fractions. Okay, we need to find the LCM of denominator. If you are finding the LCM of these two denominators, that is 5 by 4 and 3 by 2, that is 4. The denominator of 4 and 2 fractions, LCM of these two denominators 4 and 2 is 4. Next, what we are supposed to do to balance the chemical equation, we need to multiply the whole equation by the LCM. We need to multiply the whole equation by LCM of the denominator, that is 4. Now let us do that. This is the equation. Let us multiply this equation by 4 and simplify to get the balanced chemical equation. If you are doing that, what do we get? Here 4 cross NH3, that is 4NH3 plus 4 cross pi by 4 of oxygen, that is 4 cross 4 it will remove, it is 5 oxygen to form 4 NO, then it is equal to 6 amount of H2. If you are multiplied the whole equation by the LCM of the denominator, we get the balanced chemical equation without any fractions, that is 4NH3 plus 5O2, 4NO and 6H2O. This is about the ABCD method to balance a chemical equation in